This provides a short discussion of the BGP routing model. If you recall, routes are exchanged between peers through update messages, and of course the routers receive update messages from peers to describe paths that are reachable, and then they send update messages out to their peers to share this information. So the Cisco implementation of BGP has all the BGP routes in a separate table, and we actually looked at this via the show IPBGP command. In cases where there are multiple routes to the same destination, you might recall from our discussion of show IPBGP, the best path is flagged with a greater than sign in that output. So BGP does not flood all its known paths to neighbors. In fact, it only picks the best one, what it decides is best, and we'll have a detailed look at what best means later, and the criteria for choosing the path that's deemed to be best. But only the best one that's chosen is passed along or advertised to neighbors. And of course, in addition to passing on routes that's learned, BGP also will announce its own routes into the table, and then those will be advertised outwards. Now, the best routes, so to speak, after being processed and so forth, will find their way into the routing table, because ultimately every time a router gets a packet with a destination, the thing that either sends it out or doesn't send it out is the IP routing table. So that's always the table that's used to decide what to do with packets. So here's a picture that Cisco's provided with respect to how BGP updates flow and where the points are that affects the various tables. So on the left here we see routes received from different peers, and they'll be filtered or manipulated, perhaps with attributes manipulated through, let's say, route maps or something similar. We call that the input policy engine. Then there'll be a decision process where the best route is chosen, and again we will speak of that later in great detail. But the decision process here is based on then all these routes that we find in our BGP table. And then, of course, there'll be some routes that are entered into the IP routing table. And before we advertise them out to peers, there'll be another stage where there's filtering of the attributes or manipulation and so forth based on policy to our neighbors. So again, this is termed the output policy engine, similar to the input policy engine from the receiving side. And then on the far right we see the routes being sent out to our peers, so external and internal peers. So in this architecture then, the BGP table with all the routes is kept separate from the IP routing table, which only contains possibly the best route, and possibly some of these routes in the BGP table won't find their way at all into the IP routing table. So from that I came up with a flow diagram of my own. I think that clarifies it a little bit better. So on the left, the different ways in which routes can enter the BGP table are locally via network command in BGP or redistribution into BGP, possibly received from an internal peer, an iBGP peer, or possibly received from an external BGP peer. All of this is subject to being manipulated through the input policy engine, so attribute manipulation and policies right there. And after that filtering, they will be placed in the BGP table. From the BGP table to any one particular route signature, so remember that's a prefix and length, then the single best path for each prefix length will be chosen and will be categorized as our BGP best path. Now notice here I've got this rectangle as a dotted outline. That's because this isn't really a table unto itself, but really it's a subset of this table, of the full BGP table. But I show it here like this because it's really from the best paths that the IP routing table might be chosen. I say might be because obviously just because it's a BGP best path doesn't guarantee it'll go in here. And then also from those best paths, those are the ones that are eligible to be sent out to neighbors after being filtered by, again, our output policy engine. So this is where these then will be advertised to internal BGP or external BGP peers.